Okay, first problem, say write each number as a product of a real number and I. So 22, they give us the square root of negative 36. So ignoring the negative for the moment, what's the square root of 36? 6. Because there's a negative under here, all I do is write 6i. And that would be the answer. So that's what they mean. A real number times an imaginary number. That's what they're getting us to do. A real number in I is what it says. 28, negative square root of negative 80. Is 80 a perfect square? No. So, what might I need to do? Take out what?
Well, what we did. Wait. You do like the little tree and then you take
Mm-hmm.
that.
Yep. Yep, little factor tree. So, what can I break 80 into?
8 and 10.
8 and 10. Thank you for not saying 2 and 40. I hate when I have like the factor tree that's like going down like one side like really, really long. All right, what does 8 break into? 2 and 4, and 4 is 2 and 2, and then what about 10? 2 and 5. So I take things out in groups of 2s, so I'm taking out a group of 2 there. I have another group of 2, and then I have 5 left over. So that means I'm taking out a 4 total. So that's going to give me this negative sign outside stays, so negative 4. What does that leave me with inside? Negative 5, but what if I want to get rid of the negative? What can I do? Huh? So the I is going to come out. So it's going to be negative 4i times the square root of 5. And some people say, like, you should write the I at the end, but I don't really care in this context because it gets confusing and looks like it's written underneath. So I, a lot of times, will just write it like this. But however you end up writing it is okay on that. If it says it has to be in standard form, then the I has to be at the end, but these ones don't specify that. Find each product or quotient and simplify the answer. So 30 is the square root of negative 17 times the square root of negative 17. So there's 2 ways I can go about this. I can multiply the stuff that's underneath the radicals and like save a whole bunch of steps, or I can take out an I from both and end up with I squared and then multiply all of that, which is a lot more. So what I would recommend personally is to say this is the square root of negative 17 times negative 17. What happens when I have a negative and a negative? Becomes a positive. So then I have 17 times 17. What's the square root of that? 17. And that would be that. How about 34? The square root of negative 70 over the square root of negative 7. What can I do when I have a radical on the top and a radical on the bottom?
Put the entire thing under one radical.
Put the whole thing under a radical. So this would become the square root of negative 70 over negative 7. Then what is this going to become? Positive 10 underneath, so the square root of 10. And that would be your answer to that. Let's see, 40. I've got the square root of negative 12 times the square root of negative 6 over the square root of 8. So I'm going to multiply across the top first. So if I do the square root of negative 12 times negative 6, what does that give me under the radical?
36.
No.
72.
72. I'm going to go ahead and write this as one big radical over 8. What is that going to reduce down to? Square root of 9, which is 3. Write each number in standard form. So now they give us negative 9 minus the square root of negative 18 over 3. So now both things are not under the radical, so I can't combine the stuff on top, but I can like pull things out and simplify it down as much as possible. What happens with this negative under here?
Becomes positive.
How? Turns into I, yes. So this is going to become negative 9 minus I times the square root of 18 over 3. Can I break down 18?
This.
Into what? 2 and 9, and 9 breaks into 3 and 3. So I can take out a 3, and I'll be left with a 2 underneath. So this would give me negative 9 minus 3i times the square root of 2 all over 3. Some people start to leave stuff here, and I'm like, no, you can't do that. I need to break it up into its individual parts. It needs to be in standard form, which is a plus bi. So I need to write this as negative 9 over 3, which is going to end up reducing, but I'll wait and do that in the next step, minus 3 root 2 over 3 times I. That's in standard form, but it's not reduced all the way yet. What does this reduce to? Negative 3. What about this over here? Yep. Minus square root of 2i, because those 3's will end up canceling. That canceled and left you with a 3 there. So this would be your answer in standard form, in the correct way. Find the sum or difference, write the answer in standard form. 48, I've got in parentheses 4 minus I, plus, other parentheses, 8 plus 5i. So just like, I kind of like to think about the I as like an X, because I can only combine things that look the same, so I can't like actually combine the 4 and the I here. I can only do the 4 and the 8, and then the negative I and the 5i. So 4 plus 8 is 12. Then negative I plus 5I would be 4I. So the answer would be 12 plus 4I. (52) in parentheses negative 4 minus I minus in parentheses 2 plus 3I plus in parentheses negative 4 plus 5I. So if you want to do this one in steps, you can. Or if you want to do it the way I'm about to do it, that's also totally fine. So I'm going to do this. Negative 4 minus 2 is negative 6 plus negative 4 is negative 10. So that's my real part. So basically, if you wanted to do it in steps, you could just write, like, combine these first two and then add the last piece and then just go and do it again. But you can just work across. Just make sure you pay attention to signs here. Negative I minus 3I is negative I minus 3I is negative 4I plus 5I is I. So you get negative 10 plus I. This next one's kind of interesting, so I'm going to do this one. 54, I've got 3 square root of 7 minus, in parentheses, 4 square root of 7 minus I, close the parentheses, minus 4I plus, in parentheses, negative 2 root 7 plus 5I. So remember, with adding radicals and stuff like this, I can only add them if they have like the same radical and I don't add what's inside. I'm only adding what's in front. So when I do this one, I'm going to be combining these things together, but I've got to be mindful of the sign that's in front of them. So 3 root 7 minus 4 root 7 would be what?
7 root 7.
Minus.
Negative.
Negative. So this would be a negative root 7. I'm going to erase that in just a second. Minus 2 root 7 would be what? Negative 3 root 7. So I'm going to rewrite it like that. So I've taken care of all those pieces. Now, critical thing to remember here is this negative sign also has to go over here. So negative times negative I is positive I. So I have I minus 4I, which is what? Negative. Negative 3I plus 5I is 2I. So that would be your solution on one like that. They're a little trickier, so it might be better to work in pieces or like go ahead and multiply that negative sign through to begin with. However you need to do it to make sure you get all the pieces and watch the signs is fine. 56, negative 2 plus 3I times 4 minus 2I. So these ones are find the product and write in standard form. So I just follow normal FOIL rules when I do this for getting these. So negative 2 times 4 is negative 8. Negative 2 times negative 2I is a positive 4I. 3I times 4 is 12I. And then 3I times negative 2I is negative 6I squared. Now, what is I squared? -1. So this piece right here is going to become a +6, okay, because of the I squared. So now combine like terms and put it in standard form. -8 plus 6 is -2. 4i plus 12i is 16i, so plus 16i, and that would be your answer on that one. $60, you got 2 plus I squared. So this is a special type. Anybody recognize which one it is? It is a perfect square trinomial, but if you didn't recognize that, all this would tell us is to do 2 plus I times 2 plus I, and then you can just FOIL it like normal. So 2 times 2 is 4, plus 2i, plus another 2i, plus I squared. The square didn't write. There we go. I squared is -1. So combine like terms. 4 minus 1 is 3, plus 4i. See, 68 I times 2 plus 7i times 2 minus 7i. Ignoring this I in the front, do you recognize what special type this is?
Difference of squares.
It's a difference of squares. These are also obviously complex conjugates since it's a difference of squares. So when I do this, it's just the first term squared times, minus the second term squared. So it's going to be I times 4 minus 49 I squared. But we know that I squared is -1. So this is going to become plus 49 in here. So I'm going to end up with I times 4 plus 49 is 53. So we're going to get 53i in standard form. So to be in standard form, we just have to have the I at the end. There doesn't have to be like a number out front for it to officially be in standard form. All right, and then the final stuff in this section is finding the quotient and writing the answer in standard form. So we'll be doing a lot of multiplying by the complex conjugates. So with 74, I've got 14 plus 5i over 3 plus 2i. So the problem with this one is I have an I on the bottom, so I need to multiply by the complex conjugate top and bottom, and what would the complex conjugate of 3 plus 2i be?
Can you repeat that?
What would the complex conjugate of 3 plus 2i be?
So 3 plus 2 times the square root of -1.
I said that the complex conjugate of a plus bi was a minus bi. So, what would the complex conjugate of 3 plus 2i be?
3 minus 2.
Yep, 3 minus 2i. So we multiply by that top and bottom. Because on the bottom, that gives me a difference of squares, which is going to end up giving me 9 minus 4i squared. On top, I need to FOIL, so 14 times 3 is 42. 14 times negative 2i is negative 28i. 5i times 3 is 15i. 5i times negative 2i is negative 10i squared. So this negative 4i squared on the bottom is going to become a positive 4. On top, this negative 10i squared is going to become a positive 10. So rewriting things in order, 42 plus 10 is 52. Negative 28i plus 15i is negative 13i. Over 9 plus 4 is 13. Then I just need to split it up. 52 over 13 minus 13 over 13i. And at this point we reduce, I think 13 goes into 52. Let me just check. Oh, that's not gonna work. Yes. So this goes in 4 times minus I, because 13 over 13 reduces. And so your final answer would be 4 minus I. -78, -3 plus 4i over 2 minus I. So what would the complex conjugate be that I need to multiply by here? 2 plus I. So on the bottom, I've got a difference of squares, which is going to give me 4 minus I squared. On top, I FOIL. -3 times 2 is -6. -3 times 1 is -3i. 4i times 2 is 8i. 4i times I is 4i squared. 4i squared is going to become -4. On the bottom, this negative I squared is going to become +1. So combining, I'm going to get -10 plus 5i divided by 5. Need to split it up. -10 over 5 plus 5 over 5i. Reduce -2 plus I. And last one, and we're done. 84, 5 over 9i. Now, this one's a little different, okay? What do you see that's different about this one compared to this problem here?
The i's only on the bottom.
There's only an I on the bottom. What else? Right, they're not being added or subtracted by anything. So when that happens, I can't use a complex conjugate because that's just going to end up causing more issues. So all I have to do is multiply, top and bottom by I. Because all I have to do is get rid of the I on the bottom. That's the problem child, if you will. So when I multiply this, I get 5i on top over 9i squared on the bottom. But I squared is -1, so this is going to become -9. So my final answer is going to be -5 over 9 times I. And so this one just doesn't have a real part to it, is all that happens with that one. Any questions about any of this? No, it's kind of a lot. All right, so we're pushing time, and it's Wednesday. So what I'm going to do is tomorrow is going to be a work day on this stuff. So 27, 31, 39, 53, 59, 67, 71, and 73. So you'll have the whole class period tomorrow to work on these problems and do notes for 1.4 if you haven't already done them. It's about quadratic equations and different ways to solve them. After 1.4, we're looking at a quiz. Got one up there for, I think next Wednesday is what we talked about. So we should do this section 1.4 on Friday, review Monday, and quiz Wednesday because we don't have class on Tuesday. We'll be at spiritual emphasis thing. So no need to do this tonight. You have the whole class period tomorrow and you should have more than enough time to finish it.